night, everyone, for the Elephant in AppSec. So the topic of my talk today will be about API security. A lot of hype around API security in the past years, but today's talk will be about how we have been doing API security wrong, and more specifically, why API security hasn't seen as much adoption as the threat API represents for organization. Very quickly, I'm Tristan. I'm an ex-researcher in machine learning applied to scalable source code analysis. I got hacked through an API. So I decided to create an API security company. And today I'm helping application and product security professionals secure the modern web at enterprise scale with minimal friction. As the co-founder of Escape, you can add me on LinkedIn using the QR code on this picture. Escape has a long history of producing research on the topic of application and API security. And the way we do research is that we do large-scale analysis of many websites or many APIs on the internet, uncovering misconfigurations or trends at global scale. We produced the State of Public APIs 2023, an analysis of more than 6,000 public APIs, the State of GraphQL Security 2024, where we found more than 13,000 GraphQL API issues, and more recently, the State of API Security 2024, the API Secret Sprawl, where we discovered 18,000 API secrets exposed by analyzing 1 million domains on the web. So all those reports are available on Escape's website, and I put the link in the QR code on this picture. But today we'll speak about API security, and more specifically, like, why is API security so complicated? So APIs are everywhere, and we mostly know about it. 83% of the global web traffic flows through APIs. Mobile apps, single page apps, B2B systems communications, and even LLM agents all run on APIs. And all digital native companies are API first, and enterprise are aggressively scaling up their API strategy right now. Our research indicates that the average enterprise company exposes 11,000 to 15,000 API endpoints online. So that's quite a huge attack surface for enterprise companies. And APIs are increasingly vulnerable. Large-scale breaches become more frequent, and everyone kind of agrees on it. So we have many examples of recent large-scale API breaches, including T-Mobile in 2023, a breach that affected 37 million of customers, Cox Communications in June 2024, OT API breach in March 2024, and as early as 2 days ago, DocuSign API got hijacked, and the hackers used it to send out fake invoices to a company and extract money. So we can see that many companies of many different industries are victims of API-related breaches. In 2022, a report by Kong API Gateway estimated that the amount of increase in API attacks would be 31% per year. But if we take a look at the recent data, API attacks surged by 21% in Q3 2024 alone. So we went from 31% per year to 21% per quarter. The reality is even worse than what was expected by the earlier predictions. And most people agree on that, right? Including consultants, researchers, and venture capitalists. For instance, APIs have become the top attack vector in 2023, according to Gartner. API security is the top one area to invest in for 2025, according to Forrester in their budget guide for security and risk. And hundreds of millions of dollars of venture capital money have been invested in API security companies. So yet we have all of that and all of this excitement against, like, for API security, but how many companies already actually adopted API security. And here I'm gonna need your help. So if you're here listening to my talk, like how many companies, like what's the percentage of companies that are actually adopting API security according to you? And you can put your answer in the chat. Come on, what are your expectations for that? I'll see the response after. So the reality is only 11% of them, only 11% of API of companies have actually adopted API security fully in their development process. So this is a very low number. And why? How can we explain that this is such a low number, right? APIs are everywhere. Breaches happen weekly. Attacks grow exponentially. Everyone knows about it. And yet companies are extremely slow to adopt the existing API security solutions. So why is that happening? Today, there are two options for API security. One is API security testing, and the other is API runtime protection. And actually, both of them failed to scale for the enterprise. So we'll see why and try to understand what is happening. Let's analyze API security testing first. So API security testing is the API version of the good old dynamic application security testing, or DAST. Very often it's done by wrappers of open source tools like OAuth that have been fine-tuned for APIs. The problem with that technique is that it leads to poor quality of results. It requires a lot of back and forth with the developers. So very often the security engineers have to ask the developers for API documentation. Then they have to ask for test credentials and API endpoints. And like the results produced are not up to the amount of energy that was actually put into the scanning. So it requires, on average, a few days of back and forth before getting set up on one single API. But enterprise companies have thousands of API services. So it just doesn't scale. In the enterprise, you have like a lot of specific challenges. And one of them is that in the enterprise, there are very few security engineers that have to secure hundreds of applications made by thousands of developers. And so no enterprise security team we spoke to had full visibility on their API inventory, exposure, and the code owners. It is simply not possible for enterprise security team to just constantly chase all the developers to get accurate API documentation. And this is what makes API security testing a huge concern in large-scale organizations. The second solution for API security is API runtime protection. So this is a new concept. It's basically platforms integrating within API gateways, content delivery networks or CDNs, reverse proxies, or with an agent, analyzing traffic, API traffic in real time, and attempts at detecting outliers and eventually block attacks. It's a modernization of network detection and response. It's like very live, very based on what happens real time in the network. This is a very interesting research topic, but there were some challenges with deploying those solutions at scale. The first one was there was a high false positive rate because in practice, most of the outliers in API traffic are not cyber attacks. They're just outliers. And that creates a high number of false positives, which makes it hard to activate the automated blocking of attacks because of how many false positives there are. The second problem was the lack of security by design capabilities. Those tools were designed for network security engineers or SOC analysts, not for the developers. So they don't really help with shifting security left or implementing security by design. It really depends on the use case, but if you want to implement security by design, this is not the right solution. And finally, and that's the biggest problem with the solutions, they are very complicated and slow to deploy because you need to integrate all gateways, reverse proxies, and CDN, which first of all requires having an inventory of them, knowing what you have, and also very often requires a lot of multi-step authorizations or layer of approvals by different teams, the security team, the production team, the DevOps, the CIO, and so on and so forth. So it has been a very difficult technology to deploy at enterprise scale. As a matter of fact, the kind of conversation that we heard during security events are like, it took us 2 years to deploy a runtime API security solution on only 40% of our APIs. And I am yet to find any true positive out of it. So this is a real thing that I heard at besides Seattle. That being said, there are many things that are super interesting with runtime, and there are many incredible teams that built incredible algorithms and technologies on runtime or incredible products. It's just that for the specific need of large-scale enterprise companies, it's very complicated to deploy. So API security continues to be a topic of high interest. And for instance, like this post by James, who also is a speaker at the Elephant in AppSec, was dated from today. So this is very recent news. So this continues to be a topic of interest, but both API runtime protection and API security testing, despite their pros and cons, never really made it to be the first step towards enterprise scale API security. So the question that we asked ourselves at Escape is, how can we reinvent API security at enterprise scale? How can we find another way, a different way to approach the problem that makes a first step towards implementing API security at scale? We thought about 3 main pillars to solve this problem. The first one is more visibility with less integration effort. The second one is minimizing back and forth between teams during implementation. And the third one, maximize engineering productivity and buy-in by better prioritization of alerts. So the idea is to strip the noise, avoid making the engineers to work for unnecessary fixes. The question is, that's nice, but how do we do that? How do we have more visibility with less integration? How do we minimize back and forth? How do we maximize engineering productivity and buy-in? And we developed a new approach for enterprise API security. We started with the easiest possible source of data, the internet, the most scalable data source available. So only with a company's domain names, we run an external discovery and we can detect exposed APIs using external techniques, detecting API calls in front-end applications, public API documentations, public code repositories. We can also identify shadow or unofficial API clients that are stored on forums or on GitHub or on different code repositories. So this is very easy and it requires 0 effort. The second thing is integrating with the code repositories and a read-only access. Using this integration, we can identify the first-party and the third-party APIs that are used by every code repository because we have access to the source code. We can identify the API code owners. We can identify documentation of APIs and even generate documentation for APIs that don't have one. So we already get a pretty good visibility on what is exposed on the internet and what is actually made by the developer inside of the company. And then we can progressively integrate in the CI/CD pipeline, security by design, perform automated, self-configured API security testing, detection of vulnerabilities, misconfiguration, sensitive data exposure in either blocking or non-blocking mode, which heavily depends on the company's culture of DevSecOps or DevOps, and also suggest code fixes to developers to facilitate their remediation and save them time. Okay. All of this data is then unified and correlated together in a searchable, filterable, actionable set of insights from code to Internet Explorer, which can be used in workflows, ticketing integrations, compliance, and reporting. So all of this data that we gathered with the minimal amount of effort possible at the largest scale possible, we then correlate it and allow all the security team, all the engineering team to filter it, to search, to create workflows, to automate all the processes, and to use the data where it's best of use. So this is nice. I explained the integration, but how does it actually works? Like, how can we make all of that to work without having access to the actual API traffic? And that's the trick here. We created a technology that is called the feedback-driven API exploration. So it's an hybrid approach to API security. We analyze the backend code or the front-end code, and we extract the API information by doing static code analysis. When we have the information from the API, we then run a dynamic API analysis because we know the routes, we know the parameters, the types, and so on and so forth. So we can run a dynamic API analysis where we analyze every response and request, and the algorithm self-improves by creating a dialogue, a conversation with the API. This feedback-driven API exploration algorithm has been inspired by AlphaGo and AlphaZero algorithm that were made by Google to play the Go and chess game, and they have been adapted to APIs. It allows a static plus dynamic understanding of APIs, endpoints, parameters, and the business logic. And this allows a best-in-class API discovery and testing without the need to observe traffic. It kind of acts like if a human pen tester would try to understand how an API works from the source code and pen test it in a white box mode. But it is thousands of times faster. Okay. What results do we get compared to previous solutions for this approach to API security? The results that we have so far makes us think that this is the most scalable way to implement API security. We need zero information or understanding of the API attack surface to get started. The results show up in less than 24 hours. It scales effortlessly to dozens or dozens of thousands of API endpoints. And from what we observed on current escape customers or users of the platform, it discovers around 30% of unknown APIs that the team didn't know about. And it reduces the time to set up API security testing and remediation by 60 to 90%. And also, the ability to prioritize vulnerabilities stripped almost 80% of the API vulnerabilities that were deemed as actually not relevant because the API is not exposed on the internet, or because it doesn't handle sensitive data, or because this is a development API, and so on and so forth. So those are pretty impressive results that we're really proud to have built through a technical solution that have chosen a very different approach from either API security testing on one side and API runtime protection on the other side. Okay, this is the end of my presentation. I'm Tristan. Again, feel free to add me on LinkedIn. And in the meantime, I'm super happy to answer any questions if there are some, sorry.